The main learning objectives of this programme is to give you a general understanding of the ECDIS system's architecture, its main components, its main functions and features, and above all, the system's limitations. This module contains the following subjects: Introduction to ECDIS, this chapter will give you a brief introduction to the evolution of electronic chart display systems. It will make you understand what ECDIS is, the present status of ECDIS, and some guesses about the future of ECDIS. Presenting navigational chart information on radar displays and/or on special navigational displays is not a new idea. In the 70s, several manufacturers offered systems with possibilities for presenting limited navigational chart information superimposed on the radar display or on a separate display. Due to technical limitations and high prices, even the most sophisticated of these earlier systems were only delivered in small numbers to ships. Nor Control Data Bridge was one of the early systems, providing limited chart information on the radar display. Another system with this capability was the Mitsubishi Tonac. The early integrated navigation systems, which had the possibilities of displaying a limited amount of chart information, used the Navy Navigation Satellite System, DECA, Lorentz C, radar positioning, astronavigation, terrestrial navigation, and/or dead reckoning, to position its own ship. The more advanced of these earlier integrated navigation systems, combined with the position information from several sources, for example NNSS and DECA, NNSS and LORAN, NNSS and DR, etc. For professional navigators who knew the system's limitations and took these into account at all times, these systems provided great assistance to navigation on many ships, and certainly made the navigator's job easier and more interesting. The early systems, like today's ECDIS systems, is used by untrained, unqualified personnel, pose a threat to one's own ship and crew, as well as to other ships and environment. Unfortunately, the new systems have not been made easier to use than the earlier ones. The complexity of today's system poses a threat in itself, and far more attention and resources have to be put into the human-machine interface field in order to make the systems more usable for the navigator. Electronic charts have been used in military applications for several decades. However, it wasn't until November 1988 that the International Hydrographic Organization set up a working group to develop specifications for chart symbols and colour definitions that could be evaluated by the hydrographic officers, ECDIS users and manufacturers. During the 14th International Hydrographic Conference in 1992, an international standard for exchange of maritime digital electronic chart information was established. This standard is known as S57 and consists of a data model, lists of objects, description of attributes, description of the data exchange format. ECDIS is an abbreviation for Electronic Chart Display and Information System. That is, a computerized system with the ability to display all information provided on a paper chart, together with information provided from many other sources, such as GPS, ARPA, radar, etc. ECDIS information may be divided into two main groups: chart-related information, navigation-related information. Standard requirements, functions and features for ECDIS are given in the IMO Resolution A817/19 adopted on the 23rd of November 1995. Although several manufacturers produce ECDIS systems, and ECDIS has been around for some time, relatively few ships are equipped with such systems. The number of ships equipped with ECDIS is expected to increase rapidly in the near future. As the availability of digital charts so far has been limited, and the charts available have been relatively expensive, this has contributed to relatively low numbers of ECDIS systems in the world's merchant fleet so far. Another negative factor was that ECDIS did not legally replace the paper chart before summer 1999. The human-machine interface and user-friendliness of the earlier ECDIS systems is not what the mariner wants or is likely to accept today. The technology for improvement is here, but ECDIS manufacturers have to invest more effort and money to make it a more user-friendly and better its operational safety. Operators who feel that their ECDIS system is not user-friendly and safe to use should let the manufacturer know about their experiences with the system. This is the only way ECDIS operators can put pressure on the manufacturers and contribute to better HMI. ECDIS information may include geographical chart information, lights, buoys, leading lines, traffic lanes, special areas, etc. It should be the aim of the presentation design and presentation standards to provide as much diversity and flexibility as possible, as long as the system remains simple and straightforward to use. ECDIS flexibility of presentation may include displaying, removing various types of chart and non-chart information, selecting standard chart display or detailed display, and simplified symbols or full symbols, using cursor interrogation for further details. Overlaying, removing radar video or radar target information. Overlaying, removing various other sensor information. Changing the scale or orientation of the display. Selecting true motion or relative motion. Changing screen layout. giving navigation and chart warnings. Graphical presentation of computer evaluation of grounding danger. Graphical presentation of collision danger. ECDIS has an important capability of detecting the need for warnings and alarms. Here are some examples of possible warnings. Planned route infringes the safety contour or enters a prohibited area. Display is overscale. Conversely, there is more detailed information available than is displayed. Some examples of ECDIS alarms. Ship's projected position infringes the safety contour, or a hazard to navigation. Ship's course made good pose a hazard to navigation. Priority of information is important when using ECDIS. Non-HO information should not obscure HO chart information, and information ahead of the ship along the planned route should have priority over information astern of the ship. Navigators hope and believe that tomorrow's ECDIS will be more user-friendly than the system today. A clear distinction between the need to have and the rather nice to have functions and features must be maintained. The manufacturers should only offer additional options if they are clearly useful and can be accommodated without confusing the operator. Tomorrow's ECDIS manufacturers should consult specialists in the following fields: mariners with relevant experience in use of ECDIS. The mariners can tell the system design people what is need to have and nice to have. Human factor specialists. The human factor specialists have accumulated vast knowledge on presenting information and are experienced in testing how humans react to given information. On the following pages, you will be asked some questions.